The ancient astronaut theory is a captivating idea that suggests extraterrestrials might have visited Earth in our distant past, possibly influencing early human civilization. This theory points to mysterious ancient artifacts, unusual architecture, and myths that seem to describe advanced beings. Could these clues indicate alien contact, or are they simply misinterpretations of what our ancestors experienced? Proponents of the ancient astronaut theory argue that certain historical monuments, like the Egyptian pyramids, Stonehenge, and the giant stone heads of Easter Island, are too advanced to have been created without some form of outside help. They suggest that early civilizations were either taught by or even assisted by extraterrestrial beings with advanced technology. Ancient texts and myths from around the world, such as the Sumerian descriptions of gods descending from the sky or the Vedic stories of flying machines in ancient India, are also often cited as potential evidence of alien visitation. The Nazca lines in Peru, with their massive geoglyphs that can only be fully appreciated from the air, are another example often brought up as evidence of ancient alien influence. Some proponents believe that the sheer size and precision of these designs indicate that they were created with the help of advanced beings. The idea extends to other structures and artifacts as well, such as the intricate stonework of Pumapunku in Bolivia, where massive stone blocks were cut and assembled with astonishing precision. How were these enormous stones transported and carved with such accuracy, especially given the supposed limitations of ancient technology? The ancient astronaut theory suggests that extraterrestrial visitors shared their knowledge of engineering, astronomy, and even agriculture with early humans, accelerating the progress of civilizations like the Egyptians, Mayans, and Sumerians. Ancient mythology also plays a central role in the ancient astronaut theory. Many cultures have stories of gods who came from the sky, wielding powers beyond human comprehension. The Sumerian civilization, often regarded as one of the first great civilizations, described beings called the Anunnaki, who supposedly descended from the heavens and had a significant impact on their society. Similarly, the Dogon people of Mali have intricate knowledge of the star system Sirius, which some researchers argue could only have been passed down by beings with advanced astronomical understanding. Another intriguing aspect of this theory is the global prevalence of similar themes and symbols in ancient art and mythology. For instance, depictions of beings in flying chariots or wearing helmets and suits that resemble modern-day space gear can be found across various cultures, from ancient Egypt to Mesoamerica. These similarities, according to proponents, suggest that our ancestors were recording their encounters with visitors from the stars. Could it be that these seemingly unrelated cultures were all influenced by the same extraterrestrial visitors? The ancient astronaut theory also raises questions about humanity's sudden leaps in technological and cultural development. The shift from hunter-gatherer societies to advanced civilizations, often referred to as the Neolithic Revolution, is sometimes viewed by proponents as a period that may have been catalyzed by outside intervention. The construction of massive structures, advancements in mathematics and astronomy, and the development of sophisticated writing systems all seem to have occurred in rapid succession, leading some to wonder if extraterrestrial influence played a role in these achievements. Skeptics, however, argue that these claims undermine the ingenuity and capabilities of our ancestors. They point out that many of the technological feats that seem so impressive today were well within the skills of the people at the time. Recent archaeological discoveries have often shown that ancient cultures possessed more sophisticated knowledge and resources than we once assumed. For example, the construction techniques used to build the pyramids have been extensively studied, and many researchers believe that the ancient Egyptians had the tools and organizational skills necessary to complete such monumental projects without alien assistance. The idea that ancient humans needed extraterrestrial help to achieve their accomplishments can also be seen as dismissive of their resourcefulness and creativity. The advanced engineering techniques, knowledge of astronomy, and complex societal structures of ancient civilizations were likely the result of human innovation, passed down and refined over generations. Many of the mysteries that once seemed unexplainable have, over time, been better understood through archaeological research and experimentation. The more we learn about ancient cultures, the more we appreciate their ingenuity and the incredible feats they were capable of achieving on their own. The fascination with the ancient astronaut theory, however, persists. It taps into our deep-seated curiosity about whether we are alone in the universe and whether our ancestors might have had direct contact with beings from other worlds. It also speaks to our desire to find meaning and connections in the unknown. The idea that our history is intertwined with extraterrestrial visitors is a powerful narrative, one that has been popularized by books, documentaries, and television shows. Shows like Ancient Aliens have brought the theory into mainstream consciousness, blending scientific exploration with speculation and storytelling. Whether ancient astronaut theories hold truth or simply reflect our fascination with the unknown, they challenge us to look at human history through a lens of curiosity. They encourage us to question conventional narratives and to explore the possibility that there might be more to our past than we currently understand. These questions: did aliens visit us in the past? And if so, what role did they play in our development? May never be fully answered, but they continue to inspire imagination and debate. The ancient astronaut theory is not just about the past. It also has implications for the future. If extraterrestrials did visit Earth in ancient times, what does that mean for humanity's place in the cosmos? Are we part of a larger galactic community? And could these visitors return someday? Such questions invite us to ponder our own future as a species, whether we might one day travel to distant planets and become the ancient astronauts for another civilization, leaving behind clues and mysteries for them to unravel. In the end, the ancient astronaut theory is a reminder of the vastness of the universe and the many mysteries it holds. It challenges us to keep an open mind while also valuing the evidence and achievements of our ancestors. Perhaps the real value of this theory lies not in whether it is true, but in the way it inspires us to explore, to question, and to imagine the extraordinary possibilities that lie beyond the stars. What do you think? Are the signs of ancient alien contact hidden in plain sight, or are they just another chapter in our tendency to mythologize the past? Could it be that our ancestors were in touch with beings from other worlds? Or is the real story one of human ingenuity and the timeless drive to reach for the unknown? To uncover more fascinating mysteries and explore our cosmic history, subscribe to our channel and share your thoughts in the comments below. Imagine looking up at the stars and knowing that one of them might be home to an advanced alien civilization. Not just a civilization that lives on planets like ours, but one so advanced that it has built an enormous megastructure around its star to capture nearly all of its energy. This concept, known as a Dyson sphere, has fascinated scientists and science fiction fans alike for decades. But could we actually detect such a civilization by its energy usage? The concept of a Dyson sphere was first proposed by physicist Freeman Dyson in 1960. Dyson speculated that as a civilization advances, its energy demands would grow exponentially. Eventually, they might need so much power that the only logical source would be the entire output of their home star. To accomplish this, the civilization could construct an immense structure around the star, allowing them to harness nearly all of the energy it produces. This kind of energy capture would be characteristic of a Type II civilization on the Kardashev scale. This scale, proposed by Soviet astronomer Nikolai Kardashev, categorizes civilizations based on their energy usage. A Type I civilization uses all the energy available on its home planet. A Type 2 uses all the energy from its home star, and a Type 3 civilization could harness the energy of an entire galaxy. Building a Dyson sphere would be a natural step for a Type 2 civilization, a colossal leap beyond anything we can currently imagine. The term Dyson sphere can be misleading, as it evokes an image of a rigid shell completely enclosing a star. In reality, such a structure would be mechanically unstable and incredibly difficult to construct. Instead, scientists and theorists envision other, more plausible versions of a Dyson sphere, such as Dyson swarm, a massive number of individual solar collectors or satellites orbiting the star in a dense formation, all working together to capture its energy. This version is the most realistic in terms of engineering feasibility. Dyson bubble, a series of large, lightweight solar sails that are held in place by the star's radiation pressure. These sails would be dispersed in a way that allows them to collect energy while remaining in stable positions around the star. Dyson shell, the classic idea of a solid shell enclosing the star, although this version presents significant engineering challenges, such as gravitational instability and material requirements. Detecting a Dyson sphere, or any similar megastructure, is a tantalizing idea because it represents one of the most straightforward ways to identify an advanced alien civilization. But how would we go about detecting such a structure? The key lies in energy and light. A Dyson sphere would alter the way a star emits radiation. Here are some ways we could detect it. Infrared signature. A Dyson sphere or Dyson swarm would capture most of a star's visible light to convert it into usable energy. However, not all of this energy would be efficiently used. Some of it would inevitably be re-radiated as waste heat. This waste heat would most likely be emitted in the infrared spectrum. In other words, a star surrounded by a Dyson sphere would appear unusually dim in visible light, but very bright in infrared. Astronomers have long been searching for stars with this kind of infrared excess. The Wide Field Infrared Survey Explorer, WISE, and other infrared observatories have scanned the skies looking for objects that exhibit unusual infrared signatures that might suggest the presence of a Dyson sphere. So far, while a few candidates have been identified, none have been confirmed as alien megastructures. Unusual light curves. A Dyson swarm would create complex and irregular patterns of dimming as the individual components pass in front of the star. This could result in strange light curves that do not match the usual patterns caused by planets. The star KIC 84628552, also known as Tabby's star, is an example of a star that has shown irregular dimming, leading to speculation that it might be surrounded by a partial Dyson structure. While the most likely explanation for Tabby's star is a cloud of dust, the idea that it could be a Dyson swarm captured the public imagination and reminded us of the possibility of alien megastructures. SETI and targeted searches. The search for extraterrestrial intelligence, SETI, has also taken an interest in detecting Dyson spheres. By analyzing data from infrared telescopes, SETI researchers hope to identify anomalies that could indicate advanced civilizations. They have even developed specific algorithms to sift through the vast amounts of data collected, looking for anything that defies natural explanations. Although these searches have yet to yield concrete evidence of alien megastructures, they remain an important part of our efforts to find extraterrestrial life. While the idea of detecting a Dyson sphere is appealing, there are significant challenges involved. Natural explanations. Many phenomena could mimic the signals we expect from a Dyson sphere. Dust clouds, planetary debris, and even unusual stellar activity could all produce infrared excess or irregular light curves. Distinguishing between a natural cause and an artificial one is extremely difficult. Technological limitations. Our current technology may not be sensitive enough to detect a Dyson swarm around a distant star, especially if the components are small or dispersed. Additionally, If an alien civilization were to build a Dyson sphere, it might be optimized in a way that minimizes waste heat, making it even harder to detect. Different technologies. It's also possible that an advanced civilization might use a form of energy capture or technology that we cannot currently conceive of. The Dyson sphere is based on our understanding of physics and engineering, but a more advanced civilization might have entirely different solutions to their energy needs. The search for Dyson spheres is part of a broader effort to understand how energy usage might signal the presence of alien civilizations. As a civilization grows, its energy requirements increase, and how it meets those needs can tell us a lot about its level of technological advancement. The Kardashev scale provides a useful framework for this, with Dyson spheres representing a significant milestone in the transition from a Type 1 to a Type 2 civilization. In a way, searching for Dyson spheres is about looking for evidence of a civilization that has learned to fully harness the resources of its home system. It suggests a society that has moved beyond the challenges of planetary life, solved its energy problems, and expanded its reach. This concept ties into the broader questions we often ask. What is the fate of advanced civilizations? How do they overcome existential challenges? And could a Dyson sphere be a solution to what we call the Great Filter, the unknown barriers that may prevent civilizations from surviving long enough to become interstellar? Detecting a Dyson sphere would be one of the most profound discoveries in human history, providing direct evidence that we are not alone in the universe. While we have yet to find definitive proof of such megastructures, the search itself is valuable. It pushes the boundaries of our technology, challenges us to think beyond our planet, and reminds us of the vast possibilities that exist in the cosmos. As we continue to explore the stars, we keep our eyes open for any sign of advanced civilizations, whether they come in the form of unusual infrared signatures, strange light curves, or other unexpected phenomena. The search for Dyson spheres is a reminder that the universe is full of mysteries, and that some of those mysteries may point to the presence of other intelligent beings, striving to harness the power of their star, just as we might one day strive to harness ours. To explore more cosmic mysteries and dive deeper into the universe's secrets, subscribe to our channel and share your thoughts in the comments below. For years, the notion of extraterrestrial visitors has captivated humanity, inspiring countless theories, debates, and even government investigations. The conversation about unidentified aerial phenomena, UAP, colloquially known as UFOs, is finally shifting from the realm of science fiction and conspiracy theories to serious academic inquiry. A pivotal driver of this transformation is the Galileo Project, an ambitious initiative launched in July 2021 by Harvard University astrophysicist Avi Loeb. The Galileo Project aims to bring the search for extraterrestrial technological evidence under the spotlight of rigorous, transparent, and systematic scientific research. By doing so, it hopes to demystify UAPs and address one of the greatest questions of our existence. Are we alone in the universe? The inception of the Galileo Project can be traced back to the unexpected and enigmatic visitor that passed through our solar system in 2017, an interstellar object known as Oumuamua. Unlike anything astronomers had seen before, Oumuamua exhibited characteristics that led Avi Loeb and other scientists to speculate that it might not be a naturally occurring object. The peculiarities of Oumuamua, combined with other unexplained aerial phenomena documented by military pilots, motivated Loeb to propose a more systematic approach to studying such anomalies. This curiosity laid the foundation for the Galileo Project, named after Galileo Galilei, the astronomer who challenged conventional thinking and changed our understanding of the cosmos. The Galileo Project is dedicated to exploring and understanding UAPs and other potential extraterrestrial artifacts using a scientific methodology. Its mission revolves around three key research areas: detection of UAP in Earth's atmosphere. The first goal of the Galileo project is to detect and study UAPs in Earth's atmosphere using a network of high-tech observatories. The project plans to deploy an array of ground-based observatories equipped with state-of-the-art sensors, telescopes, and artificial intelligence algorithms. These observatories aim to capture high-resolution multimodal data on UAPs, providing the level of detail needed to move beyond anecdotal evidence and build a reliable database of observed phenomena. Investigation of interstellar objects. Another core focus of the Galileo project is to investigate anomalous interstellar objects that pass through our solar system. These objects, like Oumuamua, could potentially be artificial in nature. By studying their trajectories, composition, and behavior, the project aims to determine whether any of these interstellar travelers could be evidence of extraterrestrial technology. Search for extraterrestrial satellites. The project also aims to search for potential extraterrestrial satellites orbiting Earth. Unlike the satellites that humans have launched, the Galileo project wants to determine if there are any non-human-made artifacts in Earth's orbit, a possibility that could reveal previously unknown technological presences around our planet. The approach taken by the Galileo project stands in stark contrast to the way UFOs have traditionally been studied. Until recently, the topic of UAPs was often relegated to tabloid sensationalism or brushed aside by mainstream scientists. However, the United States government has recently released declassified reports acknowledging the existence of UAPs, with no definitive explanations for many of the sightings reported by military personnel. These revelations have opened the door for more credible scientific inquiry, and the Galileo project aims to lead this new era of discovery by adhering to strict empirical standards. The Galileo project emphasizes the importance of collecting high-quality data. It plans to make its findings publicly available and subject to peer review, a crucial step in bringing legitimacy to the study of UAPs. By employing ground-based observatories with advanced technologies and ensuring transparency, the project hopes to eliminate the stigma associated with UFO research. Since its inception, the Galileo project has made significant progress in establishing the infrastructure needed for its ambitious goals. By December 2024, several observatories had been established and equipped with state-of-the-art sensors capable of collecting data on potential UAP sightings. These observatories operate continuously, scanning the skies for any anomalies that could represent technological artifacts from other civilizations. In July 2023, the Galileo project garnered significant attention when Avi Loeb and his team reported the discovery of unusual material from the seafloor that they suggested might be interstellar in origin. This discovery, while controversial, sparked an exciting debate within the scientific community. If confirmed, it could represent the first physical evidence of interstellar matter accessible for analysis, and potentially even an extraterrestrial technological artifact. The project has also been active in building collaborations with institutions and researchers across the globe to advance the study of UAPs in a systematic and credible manner. The Galileo project is significant not just because it is searching for extraterrestrial life, but because it represents a broader shift in how the scientific community approaches unexplained phenomena. By treating UAPs as a legitimate area of scientific inquiry, the project challenges outdated taboos and opens new possibilities for understanding our place in the universe. For too long, the study of UAPs has been hampered by stigma, secrecy, and a lack of rigorous methodology. The Galileo project's commitment to transparency, data-driven analysis, and peer review aims to rectify this, bringing UFO research into the mainstream scientific community. The project's name is fitting. Galileo Galilei faced fierce resistance when he challenged the prevailing views of his time, yet his work laid the foundation for our understanding of the cosmos. Similarly, the Galileo project may well lay the groundwork for a new era of discovery, one that brings us closer to answering the age-old question, are we alone? Looking forward, the Galileo project has much work to do. As technology continues to advance, the potential for detecting and understanding UAPs and interstellar objects will only grow. The establishment of additional observatories, coupled with advances in AI and sensor technology, will enhance the project's ability to detect and analyze aerial anomalies. Moreover, the ongoing analysis of interstellar materials and potential collaborations with government agencies and other research institutions could yield breakthroughs that were previously unimaginable. The Galileo project is a bold endeavor, and whether it ultimately finds conclusive evidence of extraterrestrial technology or not, its efforts will undoubtedly expand our understanding of the universe. By applying the scientific method to one of the most intriguing mysteries of our time, the Galileo project is helping to bridge the gap between speculation and science, encouraging humanity to look up at the stars with both curiosity and critical thinking. To stay updated on groundbreaking discoveries and unravel the mysteries of UAPs, subscribe to our channel and share your thoughts in the comments below.
In 1960, humanity took its first step toward answering one of the most profound questions: are we alone in the universe? This endeavor was known as Project Ozma, a groundbreaking attempt to detect signals from intelligent extraterrestrial civilizations. Led by astronomer Frank Drake, who was a pioneer in radio astronomy and had a deep interest in the search for extraterrestrial intelligence. Project Ozma became the first modern scientific initiative dedicated to searching for alien signals using radio telescopes. Drake's expertise in radio wave detection and his innovative approach to exploring the cosmos made him the ideal person to lead such an ambitious project. It was a bold move, reflecting humanity's innate desire to explore and understand the cosmos, and it represented a major leap in the field of radio astronomy. The project was conducted at the National Radio Astronomy Observatory in Green Bank, West Virginia. It was named after Princess Ozma, the ruler of the distant and mystical land of Oz in L. Frank Baum's novels, symbolizing the quest to explore unknown and far-off realms. With this inspiration, Drake aimed to establish contact with civilizations beyond Earth, embarking on an exciting and uncertain journey. The sense of adventure and the hope of discovering intelligent life fueled the project, drawing the attention of both scientists and the public. It was a moment when science fiction seemed to intersect with reality, offering the tantalizing possibility that we might not be alone in the cosmos. Drake utilized an 85-foot radio telescope to target two sun-like stars, Tau Ceti and Epsilon Eridani, located approximately 11 light-years away. These stars were chosen because they closely resembled our own sun, increasing the possibility that they might host planets capable of supporting intelligent life. The telescope was tuned to a specific wavelength of 21 centimeters, 1,420 megahertz, corresponding to the natural emission of neutral hydrogen. This hydrogen line is significant in astronomy because it is a naturally occurring frequency that is easily detectable, making it an ideal choice for searching for potential signals from extraterrestrial civilizations. This frequency was considered an ideal universal hailing channel, since hydrogen is the most abundant element in the universe, making it a logical choice for potential interstellar communication. By choosing this frequency, Drake hoped to increase the likelihood that any intelligent civilization, using similar logic, would be broadcasting on the same channel, thus making contact more achievable. The technical setup for Project Ozma was relatively straightforward by today's standards, but at the time, it was cutting edge. The radio telescope was equipped with a highly sensitive receiver, capable of detecting faint signals from distant stars. The equipment had to be carefully calibrated, and the observations were meticulously planned to avoid interference from Earth-based sources. This meticulous approach was crucial in ensuring that any detected signal could be confidently attributed to extraterrestrial origins. The project's simplicity also underscored the elegance of the idea that with just a single dish and a simple receiver, humanity could potentially hear whispers from across the galaxy. Over 4 months, Project Ozma conducted about 150 hours of intermittent observations, scanning the stars for any unusual radio signals. Although the search ultimately did not detect any definitive signs of extraterrestrial intelligence, it did experience a brief moment of excitement. On April 8, 1960, the team received a signal that seemed promising, only to discover that it was actually from a high-flying aircraft. Despite the lack of success, Project Ozma marked an important milestone. It paved the way for subsequent SETI projects and helped validate the search for extraterrestrial intelligence as scientifically plausible, demonstrating that it was possible to use radio telescopes to search for intelligent signals from other civilizations. The project highlighted both the technical challenges and the potential rewards of SETI research, and it showed that such an endeavor was within the reach of human capability. The excitement generated by Project Ozma was palpable, and it had a profound impact on both the scientific community and the general public. People were captivated by the idea that we might be on the verge of making contact with another intelligent species. The project's outcomes, while not immediately successful, opened the door to a new era of exploration. It inspired a generation of scientists to think beyond the confines of our planet and to consider the broader implications of finding, or not finding, other forms of intelligent life in the universe. This shift in perspective was crucial in shaping the direction of future astronomical research. The legacy of Project Ozma extends far beyond its initial 4-month run, serving as a pivotal moment that bridged early curiosity with long-term scientific commitment to searching for extraterrestrial intelligence. It laid the foundation for future SETI, Search for Extraterrestrial Intelligence initiatives, demonstrating both the feasibility and the allure of this type of research. In the 1970s, Ozma II expanded the search to more stars, and since then, the SETI movement has grown into a worldwide scientific effort. With advancements in technology and methodology, today we can scan millions of stars across multiple frequencies, significantly increasing our chances of discovering something remarkable. The introduction of powerful radio telescopes, advanced computing power, and sophisticated algorithms has transformed SETI from a speculative endeavor into a serious scientific discipline, capable of processing vast amounts of data and filtering out potential signals of interest. The evolution of SETI has seen the development of international collaborations and the use of an array of instruments, such as the Allen Telescope Array and the Breakthrough Listen initiative, which have taken the search to unprecedented levels. These initiatives are capable of scanning vast portions of the sky and analyzing data in real time, allowing for rapid identification of potential signals. This progress reflects the resilience and determination of the scientific community to continue the search, even in the absence of definitive evidence. The spirit of Project Ozma endures in these modern efforts, as each new advancement brings us closer to answering the question of whether we are alone. Project Ozma also inspired popular culture, influencing writers, filmmakers, and artists who imagined what contact with extraterrestrial civilizations might be like. For example, Carl Sagan's novel Contact, which was later adapted into a film, drew heavily on the themes of listening for extraterrestrial signals, directly reflecting the influence of Project Ozma. The concept of listening to the cosmos for signs of intelligent life became a theme that captured the imagination of people around the world, turning what was once the domain of science fiction into a legitimate scientific pursuit. The search for extraterrestrial intelligence has since become a symbol of humanity's collective curiosity and desire to understand its place in the universe. Books, movies, and television series often draw inspiration from the idea of receiving a message from the stars, exploring both the excitement and the potential dangers of such contact. Moreover, Project Ozma had a lasting impact on the scientific methodology used in SETI research. It established the importance of using specific frequencies that are likely to be understood by other civilizations, and it highlighted the need for careful analysis to rule out false positives. The experience gained from Project Ozma informed subsequent projects, leading to more sophisticated techniques for detecting, verifying, and interpreting signals. Today, SETI researchers use machine learning algorithms to sift through vast amounts of data, identify patterns, and distinguish between natural and artificial sources. This continuous evolution of technology and methods is a testament to the enduring influence of Project Ozma. Project Ozma was an act of cosmic curiosity, a bold declaration that humanity is ready to listen to the stars. Though it did not reveal any alien civilizations, it ignited the passion of countless astronomers and dreamers, inspiring decades of exploration and a continued quest to answer the age-old question, are we alone? The spirit of Project Ozma lives on in every subsequent attempt to reach out to the cosmos reminding us that even if the answers remain elusive, the journey itself is profoundly meaningful. It represents our willingness to look beyond our world, to embrace the unknown, and to keep asking questions that push the boundaries of our knowledge and imagination. The search for extraterrestrial intelligence is more than just a scientific endeavor. It is a reflection of our deepest aspirations as a species. It embodies our desire to connect, to learn, and to expand our horizons beyond the familiar. Project Ozma was the beginning of that journey, a journey that continues to inspire us to look up at the night sky with wonder and hope. It reminds us that the universe is vast, full of mysteries yet to be uncovered, and that the search for answers, no matter how challenging, is always worth pursuing. In this spirit, Project Ozma remains a beacon of human curiosity, a reminder that our quest to understand the cosmos is an essential part of what makes us who we are. The universe has a way of surprising us with its mysterious phenomena. Among the most baffling of these are fast radio bursts, FRBs, sudden, extremely brief yet extraordinarily powerful pulses of radio waves originating from deep space. First discovered in 2007, these cosmic flashes have captured the attention of astronomers and sparked intense debate. Are they a natural phenomenon, or could they be signals from an advanced alien civilization trying to communicate across the vast stretches of space? FRBs are among the most energetic events known to science. Lasting mere milliseconds, each burst releases more energy than our sun does in an entire day. Despite their immense energy, their origins remain largely unknown, and their sources have proven elusive. Most FRBs originate far beyond our galaxy, and each one is unique. Some are single bursts, never heard from again, while others repeat, creating a signature that suggests something unusual, perhaps even artificial. The concept that FRBs might be signals from extraterrestrial civilizations is a tantalizing one. After all, if a highly advanced civilization wished to send messages across vast distances, radio waves would be an efficient way to do it. Here are some reasons why some scientists and enthusiasts have considered this possibility. Repeating FRBs. Some FRBs, such as the famous FRB 121102, have repeated at irregular intervals. This contrasts with non-repeating FRBs, which are detected only once and never observed again. The repeating nature implies that whatever is generating them must be persistent and capable of producing energy repeatedly. This has led some to wonder whether the bursts could be deliberate signals sent out by an advanced civilization, like beacons calling out for anyone who might be listening. Extraordinary power. The energy involved in an FRB is staggering, and the technology needed to produce it, if artificial, would be far beyond anything we have today. Theoretically, an advanced alien society might have the capability to harness such energy to send powerful signals across space. Some scientists, like Harvard's Avi Loeb, have speculated that FRBs might be the result of advanced propulsion systems, such as energy beams used to accelerate light sails, spacecraft that ride on beams of light for interstellar travel. Non-natural characteristics. Unlike many naturally occurring radio signals, FRBs don't seem to originate from any single known phenomenon. Their suddenness and unpredictability make them difficult to categorize, and it leaves open the door to exotic explanations, including artificial origins. While the idea of alien signals is compelling, most scientists believe there are natural explanations for FRBs that we have yet to fully understand. Here are some of the leading theories. Magnetars. The current leading hypothesis is that many FRBs originate from magnetars, a type of neutron star with an exceptionally powerful magnetic field. Magnetars are known for their magnetic fields, which are up to 1,000 times stronger than those of typical neutron stars. This immense magnetic power allows them to produce enormous amounts of energy in a short time, and their magnetic instability could be responsible for the sudden bursts of radio waves we detect. In 2020, astronomers observed an FRB from within our Milky Way galaxy that was linked to a magnetar, strengthening this theory. Neutron star collisions. Another possible explanation is that FRBs are produced when two neutron stars collide. Such collisions release an intense amount of energy, potentially creating an FRB as a byproduct. These collisions are rare, but they fit the profile for some of the one-off bursts we've detected. Blitzars. A blitzar is a hypothetical object that forms when a spinning neutron star collapses into a black hole. This process might release a burst of energy that could explain some FRBs. The collapse would happen suddenly, generating a brief but intense radio signal. The notion that FRBs might be alien signals is undoubtedly appealing, but there are reasons to be cautious. For one, FRBs do not exhibit the kind of structured modulation that we would expect from an intelligent signal. If we imagine an advanced civilization sending a message, we would anticipate some form of repetition, pattern, or encoding, something that distinguishes the signal from natural noise. Furthermore, Occam's razor, the principle that the simplest explanation is often the correct one, suggests that natural phenomena like magnetars are more likely sources of FRBs. For example, in the past, the mystery of pulsars was initially thought to potentially be a sign of extraterrestrial intelligence, but it was later understood as a natural phenomenon involving rotating neutron stars. Extraordinary claims require extraordinary evidence, and so far, there is no definitive evidence that points to an artificial origin. The search for extraterrestrial intelligence, SETI, is naturally interested in FRBs, given their mysterious and high-energy nature. SETI has used radio telescopes, such as the Allen Telescope Array, to monitor several FRBs for any patterns or modulation that might indicate they are messages. These methods include searching for repeating signals, structured patterns, and frequency shifts that could point to intelligent origins. So far, these efforts have not uncovered anything that definitively points to alien intelligence. Instead, FRBs appear more like chaotic, high-energy outbursts from natural sources rather than organized, intentional messages. However, the lack of evidence doesn't mean we should rule out the possibility entirely. The universe is vast and full of surprises, and our current technology and understanding may simply not be advanced enough to decode any message that is there, if indeed a message exists. Even if FRBs turn out to be purely natural phenomena, they are still incredibly important. Studying them allows us to learn more about the extreme environments of the universe. FRBs may help us understand the behavior of neutron stars, the structure of galaxies, and even the nature of dark matter and cosmic magnetism. Each new FRB detected provides a clue that might one day unlock a deeper understanding of the cosmos. The mere suggestion that they could be signals from alien civilizations makes them even more exciting, but their significance goes beyond that. FRBs provide crucial insights into extreme cosmic environments, such as the behavior of neutron stars and the dynamics of magnetic fields. They remind us that the universe is vast, full of potential, and full of questions we haven't even begun to answer. They keep us looking to the sky, listening, and hoping that one day we might hear from another intelligence out there. Fast radio bursts are one of the greatest mysteries of modern astronomy. Whether they are the result of cataclysmic cosmic events or whispers from distant civilizations, they represent an opportunity for discovery. The allure of the unknown drives our curiosity, pushing the boundaries of science and sparking our imaginations. The search for answers continues, and perhaps one day, we will discover something truly profound among these mysterious signals. Until then, FRBs are a cosmic puzzle, one that has captivated astronomers and dreamers alike, urging us to look up and ask, are we alone? The universe is vast and full of untold mysteries, and humanity's relentless curiosity about whether we are alone drives our efforts to find signs of extraterrestrial life. Over the decades, discoveries like the WOW signal in 1977 have stirred excitement and curiosity, highlighting the possibility that we might not be the only intelligent beings in the cosmos. But in the search for life beyond Earth, a new frontier has opened up: techno-signatures. These are potential indicators of alien technology that could point to civilizations far more advanced than our own. Unlike traditional methods that search for biological evidence, biosignatures, scientists today are looking for techno-signatures, the unmistakable traces left behind by alien technologies. Just as we use radio waves, lasers, and massive structures here on Earth, an advanced extraterrestrial civilization might leave behind similar markers. Whether it's unusual energy emissions, radio signals, or even massive megastructures built around stars, these techno-signatures could be the key to answering one of humanity's oldest questions. Are we alone? What are techno-signatures? Techno-signatures are any observable evidence of advanced technological activity. They differ from biosignatures, which are indicators of biological life, because techno-signatures point directly to activities that require technology. This could include everything from radio signals to megastructures or even unusual electromagnetic emissions. Detecting techno-signatures would imply that we are not alone in the universe, and that there may be civilizations with technologies beyond our wildest imagination. One of the most talked about examples of techno-signatures are radio signals. For over 50 years, the search for extraterrestrial intelligence, SETI, has been using large radio telescopes to scan the skies. looking for any signals that might suggest interstellar communication. The idea is simple. If there are alien civilizations out there, they might be using radio waves to communicate across vast distances, just as we do here on Earth. Recent projects like Breakthrough Listen have greatly expanded these efforts. Using state-of-the-art telescopes, Breakthrough Listen scans millions of stars, looking for anomalies in radio frequencies that could be signs of alien transmissions. The search has led to the detection of several intriguing signals, but none yet confirm the presence of extraterrestrial intelligence. But radio signals are only one category of techno-signatures. Another exciting possibility is megastructures, large-scale constructions that could be built by advanced alien civilizations. One of the most famous hypothetical megastructures is the Dyson sphere, a colossal structure that would encircle a star to capture its energy. Such a sphere would radiate large amounts of infrared radiation, making it detectable by telescopes. If we were to find a Dyson sphere, it would be an undeniable indicator that an advanced civilization capable of incredible feats of engineering exists far beyond our solar system. Another potential techno-signature is laser emissions. Advanced civilizations might use lasers for communication, propulsion, or energy transmission. Scientists theorize that a sudden concentrated burst of laser light from a distant star could be a signal from a distant civilization. These types of emissions would be different from natural phenomena, such as supernovae or gamma-ray bursts, and might point to the presence of technology we can't yet fully comprehend. Recent breakthroughs and the role of artificial intelligence. The search for techno-signatures has greatly benefited from technological advancements, especially in artificial intelligence, AI. AI and machine learning are now being used to analyze the enormous amounts of data generated by radio telescopes. With these tools, scientists can sift through vast data sets to identify potential patterns or signals that might otherwise go unnoticed. For example, AI recently helped identify 8 promising signals from over 800 nearby stars. By applying deep learning techniques to the data, researchers were able to pinpoint signals that had a higher likelihood of being techno-signatures, offering a glimpse into what might be out there waiting to be discovered. Moreover, projects like Harvard's Galileo project are pushing the boundaries of techno-signature research even further. Rather than focusing solely on radio signals, the Galileo project is expanding the search to include physical artifacts. The most notable example is Oumuamua, an interstellar object that passed through our solar system in 2017. Its unusual shape, high speed, and trajectory raised speculation that it could be a probe or artifact sent by an alien civilization. The Galileo project is now studying similar objects to determine whether they could be products of advanced technology, offering another potential avenue for the discovery of alien life. The challenge of identifying techno-signatures. Despite the promising possibilities, identifying techno-signatures is not without its challenges. One of the biggest hurdles is false positives, signals that initially appear to be alien in origin, but later turn out to have mundane explanations. For instance, a signal from Proxima Centauri was initially thought to be an alien transmission, only for scientists to later trace it back to interference from Earth-based equipment. The rise of satellite constellations like SpaceX's Starlink is also complicating the search for techno-signatures. As more satellites are launched into orbit, they contribute to light pollution and radio interference, making it harder for astronomers to detect faint signals from deep space. With thousands of satellites planned for launch in the near future, this problem is expected to get worse before it gets better. The future of alien hunting. Even with these challenges, we are entering what many consider the golden age of the search for extraterrestrial intelligence. Advances in telescope technology, such as the launch of the James Webb Space Telescope, JWST, have opened new possibilities for discovering techno-signatures. The JWST's infrared capabilities make it ideal for detecting faint emissions from distant stars, and it could play a pivotal role in identifying potential megastructures or other signs of alien technology. New projects like the Square Kilometer Array, SKA, promise to revolutionize our ability to detect faint signals from across the universe. By combining the power of thousands of radio dishes spread across vast distances, the SKA will be able to detect signals from farther away and with greater precision than ever before. In addition, private initiatives like Breakthrough Starshot are working on sending small probes to nearby stars, potentially giving us a direct look at alien technologies that may exist just beyond our reach. The future of searching for techno-signatures is brighter than ever. As we continue to refine our tools and techniques, the possibility of discovering alien technology becomes more tangible. Even if we don't find evidence of extraterrestrial civilization soon, the search itself will lead to breakthroughs in technology, science, and our understanding of the universe. The quest for techno-signatures is not just about finding aliens. It's about pushing the boundaries of human knowledge and exploring the unknown. If you're fascinated by the possibility of discovering extraterrestrial civilizations and want to stay updated on the latest advancements in this field, make sure to subscribe and follow us on our journey through the cosmos.